Hi all, welcome to this next Docker session. We'll be covering a lot more commands, but before that, let's try to understand what images are in a little more detail. Um, we all know that by now that images are everything in Docker. Files and its all related dependencies combined together in file of instructions become an image. Um, um, and there are a lot of base images, for example, Ubuntu, BusyBox, Fedora, and all such base images which we'll be continuously using to build our own customized images. But most important thing here is images are layered, and each layer represents a difference, what changed from the previous layer. Now, what do you mean by images are layered? So basically, a Docker image is built up from a series of layers. Each layer represents an instruction in image Docker file. We'll be seeing what Docker files and how we actually build Docker file in the further coming sessions. But for now, let's try to understand from a very basic example. Um, let's run one command, it -d busybox bin sh. Okay, so this is a very basic command um, where we are creating, we downloaded BusyBox image from Docker Hub, then created a container and ran this bin sh command, but in detached mode, in an interactive session, but in detached mode because and we know that detached mode is something which when we run it in background, we want to run something anything in background, we use detached mode. Uh, so now each Now, let's go to Docker images. No, but before that, let's see this should be up and running. So BusyBox, as we know, Docker PS, which shows all the uh, up running containers. Docker PS shows us that. So let's try to create quickly our own image by using this container one is sensing. We'll covering these all commands in the next sessions. But just for explaining you what layers are. Okay, so now we have busy layer, which is an image which we created from busybox. And if you see, earlier busybox was not there. Busybox got downloaded when we ran this command. When we ran docker run this, for as we all know, first what it does is it will download this specific image in our local repository, and then it will create a container, and then it will execute this command. So busybox got downloaded, then we ran this command docker commit to create our own image, from this specific command. So now, right now we have an image which is up, and which we can use to create n number of containers, and it will directly give us a shell. The container will already have shell, and we can use exec command to directly enter into that interactive shell mode. But let's try to see the difference of what is the difference. Now there is another command history. We'll see it in further sessions again. But for now, I'm just trying to explain you from the meaning of layers, busy box, okay, and Docker history, busy layer 1.0. Okay, so this is the main image, busy box, and from the history command, as I will see it in the future, in few minutes. It actually shows the history of the image, how the image was created. So if you see, these are the these are the two different layers that BusyBox had, and busy layer, the one that we created, has the same two layers. You see, the same two layers, but differs only in the third layer, which is what we call as container layer. So each layer is only a set of differences from the layer above it. Okay, the layers are stacked on top of each other when we created a new container, and we have added a writable layer on top. of the underlying layers of BusyBox. This layer, as I said, is often called as the container layer. All changes made to the running container, such as writing new files, modifying existing files, and deleting files, will be written to this thin writable layer. Right now it's 0 byte because we haven't done anything. This is just a basic image that we created. We just try to just trying to show you how what is the meaning of layer. So so now as you know what exactly layers are, okay, it um, uh, we what happens in background from this specific thing. The major difference between a container and an image is the top writable layer. That's the major difference between a container and an image. By now we everybody knew that images and containers, the difference is containers are running instances of image, but the major difference, as we see here, is the top writable layer. Because each layer, and now because each layer, this is very important now, because each container, every container, like I can create thousands of containers using this BusyBox image, right? But these two layers which are coming from BusyBox are going to be same for all containers, right? So multiple containers can share access to the same underlying image, and yet have their own container layer. Let me explain this with an image. You say, so now here if you see, this is an Ubuntu image. So these Ubuntu image, these four layers are the layers of Ubuntu image, and these are the different container layers. So now the base image is going to be same. We can make several containers from Ubuntu here, and that they all would be sharing the same Ubuntu image, this, and will only differ in the top writable, which is our container layer. So that is how we manage the memory. How This is how Docker is managing the space so perfectly. Okay, so let's try to let's quickly see another command that you have already seen, Docker images. Now the default Docker images will show us all the top level images, their repositories, their tags, and their size. Now the tag is used to logically tag images. We will be seeing the entire logic, the entire concept of tag. We'll be seeing in a session how why these tags are so important. But these are used to logically tag images. Image ID here is always going to be unique, and this unique ID is we will be using to identify the images in all the future sessions. Created, it shows the number of days. As you can see, the image was created from wherever it is being used. Could be locally, as we created right now, the busy layer, or it can be from Docker Hub. Wherever it was created for the first time. For example, if you see busy layer, it is created 5 minutes ago because it was locally. But if we see Jenkins, it shows 22 months ago. That means in Docker Hub, the last update which was done in Jenkins was 22 months ago. And this last is the size. The size is the cumulative space taken up by the image and all its parent images. Okay. If you also see, for example, this busy box. This busy box has 1.22 MB space, and busy layer also has 1.221 MB space. This is same because we haven't done anything. The container layer does not have anything extra which differs from the main image of busy box. That is the reason of having the same space. So um, there are several options. There are several optional filters that we can use to search an image. For example, Docker images. and then we can use this repository and tag ID. This is one filter which we can use to make our searching quite easy. Right now we don't have images, but when you will be working with on some projects or something else, there will be n number of images which will be present, and you need to search some specific image. Then you can directly go, and if you know the name of the repository, for example, like here we know busy layer is the repository name, and then the tag ID, that tag ID that we gave was 1.1, and if we give this specific command, we'll get an output like this. Okay, or else if I give, for example, my image, this is just repository ID. If I give, it will give me all the images which have the same repository name. But if I want to see some specific version, so I can give the tag ID, which is in layman terms, it's also the version ID that we can give, and we'll get the exact output. But the most important thing is we cannot we need to remember the exact repository name. If I give like this, it return nothing. If it needs to be exact. And also we can also get the output of this in whichever format we want. As we know that the Docker client and Docker daemon talk using REST, meaning JSON format, we can manipulate all the Docker commands output. Now here we can, if I want the format to be like the image ID and the repository name, so I can give ID is the placeholder name of the image ID, and repository. So if you see, we got what we wanted. If in whichever format you want, if you want like this, it will give us like this. So we can manipulate the Docker output images in whichever format you want. If you want also the date created since, so it gives us like this. So we can manipulate the output of these Docker images in whichever format we want.